Hello everyone, in this video I am going to discuss about covalency. Okay, here covalency means the number of unpaired electrons, that means the number of single electrons present in the ground state or excited state is called covalency. So we are going to find out the unpaired electrons either in the ground state or excited state, and the number of unpaired electrons that is present will be your covalency. So or we can also say that the number of covalent bond formed by an element is called covalency. Like if I take nitrogen, so nitrogen N2, okay, so nitrogen N2. So what is the bond here? How many bonds are here? 3. So we will say that the covalency is 3. So the number of covalent bonds formed by an element is called covalency. Now let us take an example here. Let us take some example. So hydrogen, see hydrogen. The hydrogen atomic number 1. Hydrogen has atomic number 1. The electronic configuration is how much? That is 1s1. So in the ground state means the normal state. So its normal configuration is what? 1s1. So how many unpaired electrons are here? 1. So the covalency will be 1. And also we find the examples that H2, that means how many bonds are here? Only 1. So this is due to presence of 1 unpaired electrons. So the covalency is 1. Let us take another example, that is beryllium. The beryllium is hydrogen 1, helium 2, beryllium, lithium 3, beryllium 4. So beryllium is 4. How many electrons will be there? 4 electrons. So 1s 2 electrons, then 2s 2 electrons. So in the ground state, I will always consider the outermost cell or outermost electron, because the outermost electrons are involved in bonding. So the ground state, I have considered here the outermost here. So only the outermost is 2s2. So how many electrons are here? The electrons is 2. So 1, 2. So this is the normal ground state where I have taken the outermost only, outermost orbital only. So 2 electrons is present, means paired off. So I will excite it. What is excited state? Excited state means whenever they gain energy or they get energy, these electrons will try to jump into the higher, that means the higher orbitals. Okay, so it will go to the higher next orbital. So see, excited state. So 2 electrons were there. So these electrons will jump to the next one. So these electrons, 1 electron has jumped to the next orbital, that is 2p1. Okay, so now it is 2p1. Okay, initially there was no electrons here. Initially there was no p electrons. Now because of the gaining of electrons, because of gaining of energy, the electron, the s electron where there was 2 has already excited to the next orbital. So we have how many unpaired electrons? 2. So your covalency will be 2. So example BCl2. So how many bonds are there? 2 bonds. So covalency is 2. Now let's take the case of boron. That means having atomic number 5. The electronic configuration is 1s2, 2s2, 2p1, total 5 electrons. So in the ground state, let me take the outer one to explain. So 2s2, how many electrons? 2 electrons. 2p1, so 1 electrons. Now in the excited state, where it is obtained by gaining energy and the electrons has been excited, so this electron is excited to the higher, so it has already excited to the higher. Now we have how many unpaired electrons in the excited state? We have 3 unpaired electrons, so the covalency will be 3. Example BCl3. How many bonds are there? Now here there are 3 bonds, so the covalency is 3. Next, let's take the case of carbon. The carbon, the electronic configuration is 1s2. What is the atomic number? 6. 2s2, 6 electrons. So 1s2, 2s2, 2p2. So ground state, I have taken the outermost. So how many electrons in the s orbital? 2 electrons. And how many electrons in the p orbital? 2 electrons. Okay, then in the excited state, this 1 electrons will jump to the higher, that means next orbital, so it is how many unpaired electrons? 1 2 3 4. Okay, so the covalency will be 4. So we have CH4 example. Next let's take the example of nitrogen. Nitrogen has electronic configuration 1s2, 2s2, 2p3. So ground state, so this is your ground state. Here I have taken the outermost only to show the bonding. So 2s2, how many electrons? 2. 2p3, how many electrons? 3. Now we will there is 2 electrons here, and we will try to excite to the higher one, but since there is no vacant orbital here as 2, so it cannot jump to the higher energy level. Okay, so it will remain as it is. Here we will, for nitrogen, we will keep in the ground state, not in the excited state. In order to excite, similar level of energy should be there. Here it is able to excite because this of same energy level. Okay, this 2 energy level, 2 energy level. So in case of nitrogen, we will take only the ground state. So how many unpaired electrons? 3 unpaired electrons. So covalency is 3. So NH3, how many bonds? 1 2 3. But we have also worked with NH4 positive, where nitrogen is able to form 4 bonds. So this 2s electrons is also involved in bonding. So we should understand that. This 2s electrons is also involved in bonding. Okay, next P, that is phosphorus. The electronic configuration is shown here. Okay, so the outermost, this is the ground state, that means the normal state. I have taken the outermost, outermost means the last cell. Taken the last cell, how many electrons are there in 2s? 3s, 2 electrons. In 3p, 3 electrons, 1 2 3. So the covalency will be 3. So we have compounds like PCl3. So 1 2 3. So the covalency is how much? It is 3. Now we will excite the electrons. This electron has been excited to the higher. So why it is able to excite to the higher one, to the next higher? Because they carries of same energy level. See, this is 3s, this is also 3p, and this is also 3. Same energy level can excite the electrons easily. So we have how many unpaired electrons? 1 2 3 4 5. So covalency is 5. So we have compounds, this one PCl5, and it is how many bonds? 1 2 3 4 5. So covalency is 5. Now let's take the case of sulfur. The electronic configuration is shown here: 1s2, 2s2, 2p6, up to here it is 10, 11, 12, to 3s2, then 3p4, that is 14. So the ground state is what? We have taken the outermost. So in the 3s, 2 electrons is present. In the 3p, 4 electrons is present. 1 2 3 4. Let us, so how many unpaired electrons? 1 2. So we have covalency 2. So and the compound is H2S, 1 2 bonds are here, so 2 covalency. Now let us excite it. We have excited your S, we have excited this P electrons to the next orbital, that is 3d, because it is of similar energy level, 3 3 3. So after exciting, we have how many unpaired electrons? 1 2 3 4. So 4 unpaired electron means the covalency will be 4. An example is SF4. We will again excite second excitation state. So these electrons will also excited to the next higher. This paired up electrons, 2 electrons are there, will excite one to the higher one. So here it is shown here. And now after excitation, what we find here? So we find here 1 2 3 4 5 6 unpaired electrons. So the covalency will be 6. And also we have compounds like SF6. Okay, so this we are talking about what? Third series element, that means third period. This is also about third period, and this is about second period. And okay, so when we talk about the second period elements, okay, I have written here, when we talk about the second period elements, unpaired electrons in the excited state is considered to be the covalency. We will always consider the excited state. Okay, unpaired electrons in the excited state. But in case of the third period elements, both unpaired electrons in the both in the excited state as well as in ground state, whatever the unpaired electron present will be considered as the covalency. So we have considered the, see, we are not considering the ground state in the second period. This is your second period elements. So we are considering the excited state, whatever the excited state present the unpaired electrons, that is your covalency. Boron is also the second period. How many in the excited state? 1 2 3. So we are considering the excited state for the second period elements. Okay, so here also say carbon second period. So 1 2 3 4 we are considering the excited state. But in case of third period like sulfur, so we are considering the ground state 2 covalency, excited state 4 covalency, 6 covalency. So that means in case of third period, both excited state and the ground state unpaired electrons are considered. So sulfur has how many covalency? 2 covalency, 4 covalency, and at maximum 6 covalency.